I'm Michael Wittek from Merck Darmstadt, Germany, and I'm in charge of the commercial aspects of our smart antenna products. And so what you can see here is like a novel technology approach using liquid crystals to enable smart antennas that can do beamforming to connect to the new satellite constellations, like the LEO constellations, like Starlink, Kyber, and so on. But that also can be used in novel telecommunication applications like 5G.
So this is like the really the hot topic. Elon Musk's company is trying to cover the whole planet, but there's also a Chinese company doing something. There's the Amazon, the Blue Origin is going to deploy. Other companies are going to deploy, and all these need, as far as I understand, they have a big dish right now with phased array system, and it's not using liquid crystal right now. But in theory, you could use liquid crystal for that and get the cost to be lower on the dish.
Yeah, I think the big advantage of using this approach is that the manufacturing infrastructure is already there, and the LC-based antenna is also very similar to a display. So a small modification in the display line, and you can build a smart antenna in the existing manufacturing infrastructure, and that's a big plus, especially when you go to large numbers.
All right. So yeah, the liquid crystals is just huge, right? The market is doing billions and billions of displays. And how do you modify an LCD panel process to make your product?
Oh, I think there's only small modifications needed. So I think mostly then 90% is using the same technology. There's only some parts that has to be modified. I mean, we have to, for example, to put somewhat thicker metal layers onto that. So that's being modified, and then you can produce those panels in large numbers.
And how's it different, a dish that goes to the satellites and a dish that be used for optimal 5G kind of cellular? What's the difference in the way you do it?
Well, I think the basic setup is very similar. I think only the specs are different. I think for satellite communication, you need to have extreme good signal to noise reception. So because satellites are typically further away. Whereas when you use beamforming technology in an urban environment or rural environment, it's only small distances. So I think there are different requirements to the antennas there. So, and that can be modified. But the basic technology is very similar, because I think the frequencies that are being used in modern 5G that are going up to like 28, the millimeter wave is 28 gigahertz, and that's kind of in the same ballpark like the frequencies that are being used for satellite broadband communication, like the KGaA band. That's also around 20 to 30 gigahertz. So the base technology is very similar.
So as I understand, the satellites are up in the sky, right? And the 5G and base stations are kind of like on the ground. So is it like a different direction you need to go, or it's just you point a different way? Or the whole point is that you don't need to point it because you just have it, for example, on like a little thing, and then it just works in any direction?
No, I think the higher you go with the frequency of radio waves, the more directionally the waves get. I mean, look at light beams, for example. They just go into like one directions, and you need like a point-to-point line of visibility to connect that. And the same happens also when you use radio waves, higher frequencies. you need a line of sight connection. And that is extremely important factor in modern telecommunications, because the amount of data that's being transmitted is getting larger and larger. And so also then the frequencies are being used getting larger and larger. And then you end up in a frequency regime that requires line of sight. And when you have a line of sight requirement, you need antennas that can actually steer the beam. And you don't want to do that mechanically, because mechanically is always a lot of maintenance, and it has an unfortunate form factor. But you want to do it electronically, beam steering, and this is exactly where the modern smart antennas come in, the beam steering antennas. So you want to do the beam steering electronically, and the LC is one solution, and it's a very cost-efficient solution to do that.
What is the phased array, the huge, beautiful dish that Starlink is selling for $500? What kind of technology are they using? They're not using LCDs, right?
No, I mean that's a semiconductor-based solution, and semiconductor-based solutions typically are more costly. I think here we see that the Starlink antenna is extremely cost optimized, partly also of some compromise in performance. I mean, when you look directly at the antenna, it still has to move mechanically, and it can only work with the Starlink constellation, where there's a lot of satellites up there. And so our approach is different, coming from a passive technology. I mean, we are from the start, we are very energy efficient with this technology. And also, given the infrastructure there, we are from the start very cost efficient in large numbers.
Maybe you can get back to your slides and show some different things. There's already some comments in the chat. How do you combat interference? Is there I'm always thinking that the whole 4G, 5G aspect has this problem that you probably never going to have a base station for less than thousands of people. Usually they put a base station, there's thousands of people around, and they're all kind of like fighting for the bandwidth, and there's all these Wi-Fi, Bluetooth devices in people's homes. Is the stuff that you're doing, is that helping? Because you're using different line of sight kind of tech?
I think in general, when moving, for the telecommunication part, when you're moving to higher frequencies, the density of base station gets much higher. And there's many more base stations required, and this also means the energy requirement is very high for all those small base stations to connect them, and we envision this technology also to feed a lot of base stations. LC is per se, from switching, is not the fastest in switching time, but it can enable a dynamic grid of base stations, so to feed them all, and thereby to also minimize then the energy consumption, because energy consumption is probably one of the biggest topic for the 5G and 6G rollout. Another thing is also that this technology can be used for active reflectors, intelligent surfaces that reflect the beam in a certain direction in an urban environment. So this is also being tested right now. So there's a lot of applications there, also in the telecom area. But go ahead.
So to make a great 5G network, you need to maybe an order of magnitude more base stations compared to 4G, right? You need to make many more smaller base stations, and instead of cabling them all up with fiber or something, you're suggesting they could have line of sight to some kind of a bigger base station that sends them the bandwidth to each of the base stations.
Yeah. This is one use case. I mean, the other use case is to have a base station in a remote area. So I mean, like cabling up all the base station in the remote area is also not very cost efficient. I mean, you can feed that base station via satellite, for example. So that's another use case for these antennas. I mean, you can have a base station top of a mountain somewhere remote, and since it's very energy efficient, this technology, so it can be solar powered, and it can be fed then by a satellite, for example. And there are so many satellites out there. So and with the new LEO constellations, so that's also then a use case for these antennas.
There's another question coming right here. Can we cancel dishes in North Africa? Dishes destroy the view of buildings. What I'm wondering a little bit, for example, and he asked there, the question is about TV dish antenna. Is there any chance that your phased array can work for data and also for connecting for all the traditional, what do you call it, geostationary satellites that do TV broadcasting at the same time, or it's different?
Sure it can. But I think this segment, I mean, we are talking about when we look at TVs, we are talking about an antenna that's in the price range of, like, say, $50 US. And so we can't beat this at this stage. So, but technically, in principle, I mean, it's possible to do that. So.
Maybe you can show some of your slides, but while you set them up, I'm just wondering, when you have line of sight, a bigger base station sending the signal to a smaller one, why would you need liquid crystal if the base station is going to stay exactly the same place forever? Is your technology more to, like, suitable for something that keeps moving, like satellites?
No, I think when we have a network of base stations, it's always a dynamic network, and so you want to switch the load in between the base stations, and for that you would need, like, a somewhat more dynamic beam steering antenna.
All right. So you have to constantly switch where the data comes from and where it goes also?
It's constantly switch. I mean, you just had the example of TV dishes. I mean, we got a request from Asia. In Asia, for example, you have a lot of monsoons, a lot of storms, and so on, and this causes that the TV dishes are always move a little bit, and that they have to be adjusted again and to the satellite. And so people ask us, oh, why not using this technology? And this technology is perfect for that, because we have a dish on our roof, and once a storm is coming through, I mean, you have to adjust it. And so this can self-adjust it, for example. So I think it's a viable approach for the smart antenna.
It's mind-blowing idea that it's been a dream for a long time to cover the planet with internet and with these satellites, and it looks like it's happening, right? The Starlink is really happening, and so. But the question is, for example, if you have a village somewhere in Africa, how do you connect the whole village to one base station? Is just using cellular technology, or is there some other kind of like? I always thought that white spaces was going to be a thing where people are going to use those TV bands to do internet. But I guess it's also in theory just part of 5G, right?
Yeah, it's part of 5G. I mean, one thing is, I mean, you can have an antenna and connect it to some wireless like Wi-Fi device, like a router, and then you can have internet for everyone, for example, for a village. I mean, that's one use case. Or the other extreme is like you have your own antenna in the village and have your internet connection. But I think it's not only the villages, but it's also like mountainous areas. I mean, these are extremely difficult to get fiber to. So I think you can an antenna on the top of the mountain covers most of it, right?
Yeah, if I do a quick a Google search on antenna dishes, you see all these these. What is that? I don't know if that's real. So are you going to help with that? Like, how is your technology going to look like? Is it just going to be one of these white things that looks like that, or it could be completely different in terms of architecture and design or size?
It could be really flat. It could be just be integrated in a building, right? It doesn't have to look so ugly, right? Just like a flat panel. I think this is a very good point. I mean, we are receiving like a lot of requests by the automotive industry right now, because they said, oh, okay, we have Starlink, we want to use it, because there's so many use cases in the automotive industry, like autonomous driving, which needs a lot of data. So they ask, is there an antenna that can be integrated? And I think that's a really nice use case. And I think that's a use case. I mean, I think Starlink and Tesla still it's mechanical. It's still at this point difficult. So I mean, what is better than having a Tesla with a nice integrated flat panel antenna that can do the real autonomous driving, and you can watch movies even when you drive to remote areas in Nevada. You know, I mean, everybody's driven through those Death Valley. It's difficult, almost no reception there. What is better than to drive on these long highways and watch your favorite movie?
So when you take, for example, a Tesla right here, I'm sorry, I'm back on the Google search, but they're like so smooth and I'm not going to use the word silky smooth, but they're like so like, you know, like so in theory you could have your antenna just be part of the smooth design of a car, and then it would be useful to have a better like a few years ago, like 10 years ago, I was testing out this ACOS. They were doing a thing where you could capture DVB-T signal in the car, but you had to have an antenna on each side of the car, and every time you turn the car, the signal would kind of like stop working and stuff. So let's say you have a smooth antenna on the roof of the car. Can it be used for 5G plus Starlink in the same antenna, or do you have to choose what you do with it?
Well, I think a modern antenna solutions in the car. I mean, they have multiple antennas. They have an antenna just for 5G, and they will have an antenna for satellite communication. Then they will have also some antenna for Wi-Fi. So it's an integrated solution, and depending on the area where you are, the antenna chooses the best connectivity option, right? So once you're in the city and you have a very good 5G or LTE coverage, you can use that. But once you drive out of the city in the mountainous areas, so it can become necessary to use like a satellite communication, for example. So I think it's always going to be a hybrid mixed case. But the thing is, I mean, you want to have the connectivity everywhere. Because I mean, what the worst case I remember driving around is like you are in a remote area and you have no connectivity option at all. So I'm not saying you want to be on satellite all the time, but there's moment where you really need it, and that's a necessary option then. Especially when your car breaks down in a remote area, you want to have some connectivity, right?
So you can do both. You can do both with one antenna. You can do any kind of system. You could do 5G, Wi-Fi, satellites. How does it work?
No, I think this will be several antenna. This will be an antenna module with one part dedicated for satellite communication, the other part for Wi-Fi, another small antenna for radio reception, and so on. So I think it's going to be an integrated solution, and one part is gonna be a satellite antenna, and the size probably of the antenna determines then how much satellite connection you want to have. I mean, right now, I mean, we are now working with companies for Internet of Things applications, where we have a smaller bandwidth, but a very small antenna. So antenna is 10 by 20 centimeters, very small.
Like this.
Yeah, it's like really small, but I mean, you can have a basic connectivity, but then of course, when you want to have like really broadband connectivity, I think the antenna modules will go a little bit larger. And so I think we have these options, especially now with all the satellites going up, and it's not only Starlink, it's also OneWeb, it's Telesat. There's so many options to choose from, and also China is building their own constellation. There's so many options to choose from, and so many use cases. You can opt for a smaller antenna for basic communication needs, and you can opt for a larger antenna, so you have also like a Starlink-like broadband everywhere. So I think it's very exciting times now for connectivity options on the go. And it's not only the automotive case, but it's also the maritime case. I mean, you have your boat and so on, and aviation, of course. I mean, aviation. I think the last year we started to have internet on a plane. I mean, this year and last year we're not traveling. But I think when we will start traveling again, there will be so many new options, also connectivity options on the plane, so we can watch our favorite movie there and do internet as we did before, because the satellites are there and they have to be used.
So these airplanes are going to connect to the satellites?
Yeah, sure. I mean, they're
not going to connect down to Earth?
Well, they will also down to Earth. But on a typical flight, you fly over a lot of ocean, basically. And over the ocean, technically you could have some boats there, but there's no way to get a ground-to-air connectivity there. I mean, of course, it might be more cost efficient when you fly over ground to have a ground-to-air connectivity, but hey, all the satellites are there, so why not using the satellites?
There's one thing I'm thinking, in general, capitalism and competition is good to see all these different satellite companies compete. Of course, they'll make sure the technology is the best, but wouldn't it make sense that they all kind of like roam with each other and that they expand on the same network and just make it better and better, and pay each other fees to use each other's networks, and just so the Chinese could work with Starlink and just instead of competing on the same,
yeah,
if they all put 40,000 satellites up there, it's going to be a lot of satellites at the end.
I know, but I think now we are on the early days of satellite communication. And you can probably compare the early days of telecommunication. So you have one telecom company and that puts out their claims, and you've got another one puts out their claims. And so it'll probably take some time until you get a roaming onto the satellites, especially when you go on satellite constellations. Different continents and different countries might be difficult at this stage. I think what we are now observing is like the first wave of LEO communication. So I think everybody will have their own network, their own antennas. But the second wave, third wave, we will probably also see some roaming in space.
Some partnerships going on there.
Yeah, I think so. You have
They can
to.
just encrypt the data, right? If the Chinese are afraid that the Americans are going to check what they're doing, they just encrypt it and it should be fine, right?
Yeah,
Or...
I think in the long perspective that's going to happen. Right now, I mean, there's some issues there, so it's difficult to envision that right now.
Yeah.
But I think in the long run there will be some roaming.
And hopefully all these antennas will be what's it called, future-proof, or like it'd be nice to have one antenna that works with all the providers and that works with all the different kinds of antennas at different altitudes.
Yeah, I mean, so what we see now, you mentioned the Starlink antenna. The Starlink antenna only works with the Starlink constellation, and it's just for that constellation, and you cannot use for any other constellations. And we've had a lot of discussions also with satellite companies, also with other agencies, and they would prefer having an antenna that also works with different network, works also with the geos, works with other LEOs, and that's currently for Starlink, that's not possible. And so I think I think there will be not only roaming, but there will be probably at some point also some standard for satellite communication, as we've seen in mobile communication. We had the GSM standard, for example, and so we will see that probably in the second wave, third wave, we will see some standardization. But I think these are the very early times, and so now it's time to put out the claims and to see that very similar what we've seen in telecommunication.
So maybe you can show your slides again, and maybe give some background. Merck is a very famous company doing pharmaceuticals, right? But you also provide the whole, like we are doing video right now about a part of the Display Week 2021 coverage, and you're like providing a lot of the materials for all the displays, right? For LCD and everything.
Yeah. So I mean, we are Merck, KGaA in Darmstadt, Germany. So that is different from the US Merck. So that's a completely different entity. So the I say German Merck. So our business is based on three pillars like healthcare, life science, and electronics. So healthcare, just we do a lot of oncology stuff and so on, and for life science we're doing a lot of lab stuff. I mean, we are very much involved also in developing parts, lipids for vaccines, very close collaboration with BioNTech and Pfizer, but we are based in the electronics, and so this technology, LC Smart Antenna, got its roots in our activities in LC for displays. So we are a market leader in LCs and for displays, and we also do a lot of materials for the next generation displays like OLEDs. A lot of material is done there, and also lately we just added semiconductor solutions, like photoresist, all the stuff that's the semiconductor industry needs. We added to that, and we also have some nice colorful pigments. So that's the electronics part, and this is where the satellite communication and 5G part comes in. And so we took the liquid crystals and looked what other use is there besides displays. And we've identified windows, for example, and we also identified modifying microwaves. And so this is the base for the technology for the LC-based antennas.
All right. When people think about like LCD as the biggest success in display history with billions and billions of displays, is it possible for you to say how many of the LCD displays get materials from Merck, or it's not really public to say? Is like a big part of them?
It's a big part. It's a big part. It is a big part. I mean, we are market leader basically. I don't have the numbers, but a big part.
And how affordable, I don't know if we spoke specifically about it before, but how affordable can it get to make a nice, beautiful, flat beam, what do you call it, beam forming, or is it phased array also?
Yeah, beam forming or beam steering antenna. I mean,
beam steering antenna for the satellites. How affordable can it get compared to a $500 Starlink?
Yeah, I mean,
antenna?
First of all, we all believe that the Starlink antenna is subsidized, and the cost is probably different to that. But I mean, you can compare it to a TV. I mean, how much is a TV, a 55-inch or 50-inch TV? So it's when we speak of the panel, I mean, we're talking about $500 or less. And an antenna of that size shouldn't be, when produced in large numbers, the cost point shouldn't be different. So for a panel for 50-inch, I think the panel price is $200, and so an antenna, the panel should be in the same price range, plus some electronics, modems, and so on. So I think this is what we are talking about, and this puts us in a very competitive space in the industry, where typically the antenna cost is much higher.
All right. So maybe you can show some more on your slides.
Yeah, I can go on. I mean, we talked about that the topic is hot, and just to see what is the satellite communication is all about. I mean, we mentioned LEO, we mentioned MEO and Geo satellites. So originally we had the Geo satellites. So the Geo satellites is characterized that it's just it's not changing its position in the sky. So that's why you can point your satellite dish to a certain spot and it just stays there. Then we have satellites in lower orbits, closer to Earth. So the Geo satellite is 36,000 kilometers to Earth. So the signal time traveling there, it's pretty long. It's a millisecond, and it's not really suited for really online activities. So, but you can go to MEO satellites that are closer, or LEO satellites that are much closer. And then these satellites, LEO and MEOs, they are not fixed in the sky. They're moving, and so you need an antenna basically that follows them. Also, then changes then to another other satellite. But here you have the advantage; they're much closer to the Earth. So I mean, the signal strength doesn't have to be so high, and of course, then the delay times are much smaller. So we're talking LEO is like 20 milliseconds or less. So we've seen two scenarios right now. I mean, one is that the geostationers, I mean, they're really going to high throughput to get a lot of data out there. And for every car that's moving, you also need a beam steering antenna. So LEO, as you can see here, the satellite is also moving, and you need an antenna that follows then the satellite. So these are all the constellations. Here we see, I think, all the use cases where we look at. So we look at broadband consumer, which is huge. We see, and we mentioned that, is backhaul. So backhaul means like connecting your base station in a remote area using a LEO constellation. I mean, that's also an interesting use case. And then you, of course, have all the mobile segments like automotive, maritime, aviation, that will create a lot of demand for these antennas. And then you have, and we mentioned that, I think we have the automotive use cases. Right now, I think that's a very hot topic right now within the automotive, within the car industry. There's a lot of things, and we discussed that. I mean, 5G is always not sufficient, so you need to have something in a remote area, especially when you go into autonomous driving with all the sensors, with all the information that's coming in. That's going to be a very interesting use case right now we are discussing right now. So here is a video just explaining how the technology works. So here you see an example of a flat panel beam steering antenna, and you can see it's built very much in layers like a display. So you have one layer with the liquid crystals, like in a display, and like in a display, this layer modifies the electromagnetic waves. It modifies in a way that a beam can be steered as light can be steered, and it's built up like a display, and can be produced like a display, and could be put in very nice, integrated into car, airplane, and also in a boat. And it's perfectly for connecting in remote areas with all those new satellite constellations that are being launched right now.
Yeah, yeah. So hopefully you can hear me, right?
Yeah.
The sound is okay.
It sounds perfect.
Yeah. So that's is it? Are you the only ones in the world doing this technology, or do you have competitors doing exactly this, or this is like groundbreaking, and nobody's thought about it so far?
Yeah, I think we started. I mean, this technology we started 15 years ago. I think it's not something you can do like immediately. So we had a collaboration with a local university, Darmstadt, and together with the university, we developed materials suitable to modulate microwaves. And so over the years, I mean, we optimized these materials. We have and we patented, of course, all these materials, and we have a very strong position from a technology point of view and also from a patent point of view. And so we early on also working now with startups and to bring this technology into the market. And it also requires then a partner in the display industry. And I think we work now with all the major display makers. We introduced that technology, and they are now assessing that and preparing that to bring that technology into the market.
How big does the antenna get? When you talk about a $500 TV, I'm thinking 65-inch TV. You know, like I'm thinking, especially for some of these brands that make really affordable, crazy good TVs. Are we talking about the antenna could be a big one also, or smaller, or?
Yeah, as I said, depending on the performance of the antenna, it can be small or it can be larger, right? And the good part is, you can tile also. You can have smaller antennas, and you can combine them. You can have a tiled approach, which is especially useful when you have like a car roof, or you put it on your trunk. You can have smaller segments of the antenna. But as I said, you can have small antennas, 10 by 20 centimeters for base connectivity, IoT, or you can have larger antennas with much higher performance. Because for a phase antenna, typically the performance scales with the area of the antenna, and depending on the performance of the antenna you would need, the antenna is smaller or larger. So we had the example, having connectivity, a very good connectivity to a Geo Satellite, you will probably have a larger antenna. When you have a very strong signal to a LEO constellation, then the antenna can be smaller. So I think there's all these use cases there, and the beauty of the LC technology is that the cost just scales linear with the area, whereas other technologies like semiconductor, it scales with the number of chips, and the number of chips scales per square per area. So here you can have larger antennas also with a very good cost control.
Like the liquid crystals are like really a fantastic invention, fantastic for our world, for our planet, right? Humans have really enjoyed those liquid crystals over the last bunch of years, right? And Merck is in like really the top like expert in just providing this material, providing in the.
Yeah, I think Merck commercialized these liquid crystals for displays. And it was a huge success, and it still is a big success. When looking at competing technologies like OLED and so on, they still haven't penetrated like the large area displays in big numbers like TVs. It's still the major technology for TVs is still LC. And will be also for the time being, because just it's so cost efficient, and we have that. And our approach is also to transfer this technology that's being so successful in the display world, transfer that and find different applications. And I said one application, I'm not going to go into that today, is Windows. So Windows, where you can control the transmission, or you control the opacity, like so you can make them more milky. So you can control that. But these are the Windows people at Merck. They're doing that, and they're doing a fantastic job. The other case is antennas. So we see here a very similar story to that we've seen in the TV business. In the TV business, remember, you probably experienced those huge CRT TVs, those big clunky CRT TVs, and very similar. We see a very similar story in the antenna space. So coming from this big clumsy mechanical parabolic dishes, we come now to flat panel antennas. And within the flat panel antennas, there's many competing technologies. And we've seen a very similar story also with LCD, where we competed against plasma. and plasma loss, because energy consumption was one topic. So I think these are very nice parallels, and we will see how this all is gonna develop.
So I'd like a window, like it's your friends at the window team, but I'd like a window that I can control who can see through from which side, right? I want to make it opaque if I want to watch a movie on my projector, and I want it to also be a solar charger and an antenna at the same time. Is that too much to ask of a window?
I mean, we are getting there. I mean, there's always a big request for transparent antennas that will also be used for the windows, especially now when you go in the 5G millimeter wave connectivity. So typically, like when we talk about higher frequencies, they are not able to penetrate any buildings or windows anymore. You probably had this issue when you're driving a car. Some cars have those heatable windows, and there's metal in there, and so you have really bad connectivity in there. And you've got very similar issues you've got also with buildings and millimeter waves. And so I thought it's being looked at having transparent antennas, and also to integrate this into Windows. But I think this will take some time. But I think it's a valid use case, and we also talk to our colleagues in Windows to look at that, because it's becoming a big issue when you go to higher frequencies, how to get the higher frequencies into a building, to make the windows transparent to microwaves, to millimeter waves. And so that's a big topic, and that's also being looked at in the telecommunication industry.
The really awesome Boeing airplane, Dreamliner. I don't know if all of them ship with it, but it's really cool when you push this button and the window becomes dark, and I guess you say it's some kind of a metallic thing maybe that goes through the window?
It's electrochromic, so it's a different technology. I'm not going into that technology.
Yeah.
It's also a good technology. The LCs are much faster. The electrochromic is a little bit on the slow side. It takes a minute till it changes. An LC window goes snap, couple of milliseconds, and switching time is relatively fast compared to other technologies. So I think there's a lot of use cases there. So.
And I don't know if you showed this in your slides, but maybe what's it called? Maybe I can open it right here. Try to zoom out a little bit. So there's a feeding network. What's part of the feeding network? Is it like electronics, like a PCB?
Yeah, it's a feeding network. Basically, I mean, you have to get the microwaves to the individual cells. So basically, that's what the feeding network is doing, and basically, it's some feeders basically down there. And it's typically based on PCB. Yeah.
All right, and then you have the Liquidon right there.
Then we have very similar to a display. We have a layer where we have the phase shifters and the liquid crystal layer, and you can control every phase shifter. You can control using then the liquid crystal layer, and controlling the phase shifters allows you then to form the direction of the beam. That's not fully depicted in this promotional video, but this is how basically that works.
And then there's a radiating elements.
Yeah.
layer?
Once the and it's shown before, then the signal goes to the radiating elements, and it starts radiating then the radio waves. And depending on the phase shift in between each radiating elements, you can steer then the beam basically in both directions.
And there's one device that I dream, that I wonder if it's going to be able to connect to the Starlink and the other satellite networks, is the phone. What's the chance? You see those phones have they have a display, and often it's an LCD. Sometimes they do OLED, right? Wouldn't it be awesome if you could use your phone's display as an antenna?
Oh, that would be lovely. That would be lovely. But I think we are not there yet. Put it this way. I mean, as I said, with these frequencies, I mean, we require line of sight connectivity, and every time you're holding your phone, and just remember the antenna gate for one manufacturer where you covered your hand. The internal antenna and you didn't get any receptions. So typically a mobile phone has several antennas. So everywhere you cover the antenna, you get a reception. And so for millimeter wave, I think it will still take some time until we can connect a mobile phone to that. I mean, we've got asked for that, and I think there's a very strong demand. You're not the only one who wants to have this.
Because those Starlinks, right? They're so awesome, but it just sounds a little bit bulky to have this huge dish as the only way to connect. It'd be awesome if what I'm thinking. I don't know if they are at all announcing anything, but right now they have 1,000 satellites, right? But the goal is to have 42,000 satellites, something like that.
Yeah.
Maybe when there's more and more satellites and they get even lower in altitude, they can have cheaper. They can enable cheaper antennas. Maybe they enable the liquid crystal antennas, and then maybe, hopefully, it becomes some kind of really pocket size that even connects with satellites.
Yeah. I mean, I think, as I said, I mean, there might be use cases where you have a basic connectivity, like a small bandwidth with a very small antenna, so that's foreseeable. Or, I mean, what you can have, I mean, and we talked about the car. So you go camping, you have your antenna in the car, and the car also acts as a Wi-Fi station. So it has the antenna that connects to Starlink, OneWeb, to any LEO constellation, and this car acts as a Wi-Fi station. So I think that's why the automotive use case is so important. So you can use that also then to, when you go camping, for example, put an antenna on your camper. So that makes it so interesting. You can drive to any remote area. Once you are in 100 meter with your car, I mean, you can enjoy very nice connectivity. And honestly speaking, most people are not moving further away than 100 meters from their car. Probably not 90%. 10% are really hiking remote, difficult, but most people stay close to their car and so on.
I always thought that one of the things that might happen is that people will connect their home broadband to make small base stations. I forgot what they're called, like a base station at home that they can share with all the neighborhood. To make to provide pretty much like a free Wi-Fi, that kind of like but using white spaces. But now what you're just saying, it makes me think that in theory, like the Teslas or another car brand could suddenly help densify this 5G bandwidth in the maybe help in the cities, but especially help outside the cities, right? To just and share it with all the people around the car. So hundreds of meters around the car, they could connect on the car, and it goes through some kind of roaming and stuff like that, right? So,
I mean, this could be any car manufacturer, could be a telecom company.
That's crazy.
Yeah, but I think it's possible, and it's a very interesting use case. I mean, for all the cars that are driving around. Um, especially when we're talking about like electric vehicles, they always have some sort of power there. So that's also a big plus, and they can also use part of their power to be a small base station. So why not? That's
That's
all
so
doable.
awesome, because they're all going to come, these self-driving kind of like Ubers, right? That goes around and picks people up, self-driving, and in theory they could also self-drive themselves where there's need for more bandwidth.
Well, that would be that would be good. I mean, I think once you have like a soccer game or whatever, you have whatever baseball game the Giants are playing, so you can drive there.
Well, there'll be 100 Teslas around just for base station.
Yeah, but I mean, people drive there to the stadium, and they can use their cars to connect, basically. But then, of course, there are some sort of limitations from the satellites. I mean, there's not so many satellites up there.
Yeah.
But again,
as far as I understand, the satellite works better outside cities, right? It works better when there's not too densified populations, so villages and stuff.
So the dense stuff might be not the perfect use case, but again, camping in a remote area, this might be the ideal use case to act as a base station there. So that's all foreseeable, like mobile base stations. So why not?
So it could take like if it's a dense area, we do the line of sight kind of thing, and then create a lower power, smaller base station to not to provide just the people a few hundred meters around. Okay, this is a lot of talk.
Wi-Fi. I mean, like most of the phones or most of the providers. I mean, you can use Wi-Fi for your telephone. Basically, when you get into a hotspot, it's Wi-Fi, and you can use voice over IP basically. So I think that's also foreseeable then using a car then or any other platform. I mean, using a boat, for example, is very similar use case, right?
There's a question. I don't know if it was already mentioned. What is the bandwidth on focused beam antennas? What can you say about bandwidth? Are we going to be able to do gigabit per second?
Well, that depends. As I said, it's a very good question. There's the bandwidth is given basically. One bandwidth is given by the satellite, right? So a typical satellite goes 10 gigabit per second, some more. And then you have the bandwidth limitations of your antenna. That depends, as I said, if you had a very small antenna, you have a rather smaller bandwidth, or you have a large antenna, you can have a much higher bandwidth. So that is all possible.
Yeah, because I think
the Starlink is 50 megabit per second, but I think you can do that. You can do that also then on the antenna, but it really depends on the antenna size and which constellations you're using. If you're using a Geo, LEO, and so on. So it's not the easiest question to answer, but we've seen with the data of the current Starlink that you can easily go 50 megabit or 100 megabit per second.
Yeah, they're kind of like Elon Musk. He tweets about it and stuff, and they kind of say it's supposed to go to gigabit, maybe even 10 gigabit. That's what they're talking about. But when you're saying 10 gigabit per satellite, that seems limited. That seems a little bit limited. They don't have more than that per satellite. They cannot do hundreds of gigabit per satellite.
No. I think it depends on which level of technology the satellites are, and also probably also on your plan you're having with Starlink. So I think for commercial use cases, for example, when you want to link up with like a cruise ship, for example. You need a very high bandwidth. You have 1,000 people on the cruise ship, probably 10% are always online, so you need a very high bandwidth, and so you can probably have a dedicated satellite just connect to that cruise ship, for example. So I think these are the use cases there. And then also on the antenna side, I mean, you will have larger dishes or larger flat panel antennas that can connect to the satellite. So it's very much a system view, basically, you have to look at.
So there's one project I'd like to envision to see if it would be possible to do a very affordable antenna that connects to the satellite, but that doesn't need to have a stable connection that keeps sending data. It just needs to send a little bit of like some logs once in a while, kind of, and it doesn't have to be at a specific time, you know, like, so is it, you could, I guess it's possible to envision a very small one that just is, you know, like just for not so much data and goes to the satellite anyway, and it would be out in the sea. It would be totally out in the sea and just sending a little bit of data from a small antenna.
Yeah, I mean, there are projects out there, especially for remote sensing, and we've seen a lot of requests where you have buoys in the ocean for tsunami warnings, for as small weather stations and so on. You have them on volcanoes and so on, and the only way is to connect them to via satellite. And this is basically in this category IoT, Internet of Things. And so these are very small antennas, like 10 by 20 centimeters or even smaller. And they have a rather small bandwidth, but they can send real-time data always to the satellite. And this is extremely important for ocean monitoring and so on. I mean, there's so many things you can monitor. And so there's a lot of use cases out there our partners also looking at. So.
Because what I'm thinking is, let's say the waves and the storm and stuff and the boat is moving around. I don't think it's important for it to have a constant connection, but as long as it can send some data every 10, 20, 30 minutes or something like that, or every hour, few hours, it's even okay. So I'm wondering, maybe that means that it could be an even smaller and even cheaper antenna, potentially.
Yeah, it depends. I mean, you can go then also to much lower frequencies where you don't need a beamforming antenna. So for that case, but with a very low bandwidth. For like a small bandwidth, I think when you go to 10 gigahertz and so on, you need a kind of this beamforming antenna. And as I said, our partners developing IoT antennas that are 10 by 20 centimeters. With a very low energy consumption. So
and when you say they're developing, does that mean it's a project that's coming? Or it's not yet already there, right?
That's a project that's coming. So I think the prototypes are out there and they're now being tested. And so it will be available next year.
And you're happy to work with every company, like in China and everywhere, all these manufacturers, design houses, or do you work a lot with mostly European or American, or how do you do the?
Merck is a global company. I mean, we work with every partner that can bring up a viable technology approach, basically that.
All right.
So I think we are. I mean, as you know, we have a very strong presence in the LC business in Asia, because there's all the LCD panels are being produced in Asia. So
yeah, and China is huge right now with LCDs, right? They invested billions. They invested billions in those fabs. And luckily, with this strange time where everybody have to stay at home, people are buying TVs like crazy.
Yeah.
But, it's only going to go up, right? The demand, and the big partnerships could be huge right there with these fabs.
Yeah. So the demand is going up right now. It's extreme crazy times, put it this way, and we see a spike of demand because everybody is sitting at home. But that also means there's a lot of capabilities there in manufacturing there. And what is probably most important is there's a lot of, like, say, older lines that are completely written off, and they can be used as a starting point to produce smart antennas, windows, and other new technologies. So, and I think that's a big plus. I mean, you know the display industry, and we're talking of a Gen 10, 11 lines where substrate is 2.50 meters times 3. So this will be probably not the start for production for the smart antennas. Later on, for sure, but in the beginning, we will utilize smaller lines that are already written off, and so that's a very nice utilization also for the older lines to start the panel production.
This is really awesome. The TV business has been providing all the stay-at-home directives. Like people have to stay at home, but you can provide the get out of home future, right? Get out of home, go in the mountain, go in the sea, and stay connected.
Yeah, I know. That's a very, very good picture. That's true. That's true. I mean, people just want to get out of home, but what we've seen, and a lot of people now, we observe that they want to work at very nice places. We've seen that here, that people are working in their weekend houses, even in Germany now, in some, say, remote villages, we have really poor connectivity. So and this is a means to bring the connectivity also to these rural places, and also for the people who want to work in the rural places. Because now, what we've seen now here is that a lot of people are moving out of the cities into rural areas, having the home office there, and this antenna technology provides a very good means to stay connected and to be able to work anywhere you want, right?
I think this is a trend also for the future of actually now, like people would dream to have better connectivity when they go out in nature with their camping cars, right?
Yeah,
and they want to have a better connection.
Yeah, I mean, the modern work life is, I mean, you have to be connected all the time, and there is and also a standard is having a video conference right now. So people are not happy to talk on the phone just only for business. You want to have a video conference, and so I think this technology being connected everywhere just opens so many new possibilities for communication and also for working. So you can be out in the nature, do your work, and then have your video conferences using this new connectivity options, and then enjoy the nature, right?
And this is coming very, very quickly and very, very fast, right? You, at Merck, do you have experience getting technology to the mass market very quickly, right? If somebody says thumbs up, we like this, it's just going to happen so quickly.
I mean, right? we are ready. We are ready, and we also primed our partners in the display industry, and they are getting ready too. So it basically the whole supply chain is experienced. So Merck, we are very experienced in launching that material. The supply chain partners, like the display industry, is also ready to go. So yeah, we are basically getting ready. So right now the designs are being finalized, and the final testing is ongoing, and hopefully then next year we will get these antennas in first and larger numbers.
Nice, because it's I don't want to keep bringing back to the Starlink, but I'm so fascinated by the watching all the rocket launches, and they do like every 2 weeks or something. It's crazy, and so it's going to get to 1,000, then to 4,000, and then to 12,000, and all these satellites are going to be there. It'd be nice if what I'm thinking is India, Africa, all these regions that have bad connectivity, they need to have some way to connect all of them. And maybe, I don't know, it could be Germany. Let's say when Germany says they want to help Namibia, just as an example, right? They could just deploy 1,000 base stations to all the villages using this technology. And it'd be like, it's like it could change everything for all these billions of people who don't have good internet right now. If they can connect to this, but it needs to be more affordable, hopefully. And you're talking about $500, but let's see how who can pay for that or something like that.
That's not the limit. I think the beauty of these LEO constellations is there. I mean, capacity is everywhere basically, and there's capacity everywhere, and you don't want to have this capacity unused. So, I mean, there's always flying a satellite over Africa and so on. And as you can see, I mean, it's like I always compare it with like an airplane flying. I mean, you have seats that are very expensive, say like in the developed world, so there will be different plans. But then you also have seats, and the airplane is flying anyway, say seats that are untaken when the satellites are flying over underdeveloped regions that can be utilized almost for free. And so, but the limiting factor right now is really the affordable antenna, because satellites are up there, but the key factor is to have an affordable antenna, most likely in the $200 region. So I think this is the region. I think everybody says this is the spot where we have connectivity.
And if you can have just $200 and plus a little bit more electronics, and you have a base station that covers the whole village, that's like totally affordable. That's like $1 per person in the village.
That's affordable. Plus, I mean, you can bundle that with any other service, and you can bundle it to a small shop, and everybody will come to the shop because it's close to the wireless connection access point. So I think there's a big future in that, also to connecting the unconnected right now. Of course, I mean the money generation will be in the more developed regions where people go out on their camper and so on, and are on their $50 or $100 per month plan. But there will be also then in areas that are not that affluent, where you can have other plans to connect people in these underdeveloped regions. So I see it as a very big opportunity to have everybody connected.
So it costs a certain amount of billions for the Starlink company and the other companies to send all these up. But what I heard, for example, Germany is talking about working with potentially Starlink to connect 200,000 people who don't live in very good broadband areas in Germany. What I'd like to see is that countries make a deal with the Starlink and says, we pay you X billion, and then you give it a cheaper monthly cost to all the people in our country, especially in developed countries. So based on the GDP per capita, like in all the poor countries, they should pretty much have it for free, I think. Kind of like, like some philanthropic donation, or some countries should pay for it, of course, but it should be like the people in the country shouldn't have to pay $100 per month for internet. But then in the rich countries, of course, they can afford it. But you know what I mean?
Yeah. I mean, it's a very viable question, and we see it also in other cases. I think there will be ways to have a more just distribution of connectivities there. So that's a big opportunity. For sure.
And even in the rich countries, like in Germany and the US, there's like pretty much like millions of people that don't even have good broadband. Like today, I had to visit my neighbors to get internet because over there it is there's still no internet here in Denmark and this the summer house over there. So even like in developed countries, they're not so eager to get the fiber to every home because it costs thousands of euros and stuff to dig the holes.
Yeah, especially in mountainous areas. And Denmark is not mountainous, but
Yeah.
there, and Denmark is one of the richest countries in the world. So even there, and I've seen when we go for the weekend to just 50 kilometers south of Darmstadt, connectivity gets really bad. So
All right.
that's a big opportunity to get everybody connected. And also it offers then new connectivity options, like, as we discussed, like mobile access points when you integrate this into cars, any other mobile platforms. So I think it got a very big future, but I think what it really needs is affordable antennas. And I think we're working on that. And we want to leverage the infrastructure of the display industry to do that. And we have a very clear path to do that, and very much experience also in materials and our partners in the display industry to get to this goal, But still, I mean, it's a new technology, and a lot of people need to be convinced in the industry. Okay, because when I think of LCD, it's not as sturdy and reliable. But no, I mean, we've demonstrated this with all the LCD panels. We've tested in very rugged environments. Is super reliable, and the same is also going to be true for the antennas. So it's a super rugged technology.
So I guess you are very busy, but you're going to get so very busy in the future months and years, I guess, if hopefully this becomes huge. And how do you want to work with like startups, or if the startup has some new ideas, what they can do by connecting with you, or are you more like working with the huge companies that make the LCD and stuff?
No, I think we are. It's a very unique. I mean, we work with startups, and the startups do the design of the antenna panels and develop the technology. On the other hand, the startups and we also support that to connect with our display partners, and the display partners have the infrastructure to produce that. So that creates a win-win situation. I mean, the startup typically doesn't have the resources to set up their own production line and so on, and they can utilize an existing manufacturing infrastructure that's by the display industry, and also then can use their experience also to assemble those antennas. So that's a very good situation right now to go to the mass market.
The key word that I keep hearing when I see all these people that, what's it called, they tear down the antenna of the Starlink. They always talk about the phased array technology that was only military in the past, but they are kind of bringing it down to consumers somehow. When you talk about your technology, is it compatible with this whole concept of phased array antenna?
Yeah, it's so this phased array is one way to utilize the LC in this approach. The difference here is that what's coming from the military, or what people say phased array, is an active phased array. You have active chips to produce each antenna element. Here, I mean, we have, like in a display, a passive, a so-called passive layer that modulates the microwaves, and also for each antenna element sets then the phase using a passive phase shifter. So it's a very similar approach. The difference is only it's passive, and so you have advantages. In one thing is you don't need this number of active chips, so that's a cost efficiency, and also you have some efficiency in energy consumption because you only need like one element that's producing then the microwaves instead of a lot of small chips. So it's a very similar but different approach, and so it's one way to get the cost of the phased array technology down.
And also you can have any shape you want. It doesn't have to be like a rectangular or square. It could be like round or anything.
Yeah. You can change the phases. I mean, what you can do is you can tile also these elements together. So you can have certain tiles and do that. But you can have different shapes. Also, technically, I mean, we've shown that with displays you can also bend those things, but I think that's more in the future to go for more bended or conformal types of antennas. Right now, the first approach is just a very old school panel-like approach, right?
And you would just go straight up.
Yep.
You don't point it to one side or the other, or you might, right? But maybe you just go straight up.
You could. I mean, the beauty is of having this tiled approach. I mean, you can put several segments of the antenna pointing in different directions, and so by optimizing then the reception basically.
All right. Thanks a lot. Thanks for, I don't want to get into you probably have next meetings and stuff. Thanks for doing this feature film on my YouTube channel. That's great.
You're more than welcome.
And hopefully the people watching are the right people. They can contact you. Is there a way to contact you through the website or?
Website, LinkedIn, there's all these channels. I mean, you probably just Google the name and or Google Merck LC antennas, and you'll find a way to connect.
All right. Thank you very much, and thanks for helping connecting the world and connecting us in every corner of the planet. That's fantastic. That's amazing. That's really it must be a really fun job also to have, right? To be a part of the teams that can make this happen. That's really cool.
It's wonderful to work at the edge of technology. So that's always very exciting.
Great. Thank you. Thanks a lot. Thanks everybody for watching.
Bye-bye.